HVAC temp rise formula for measuring airflow CFM tells you how much air your furnace moves by comparing the heater's watts to the temperature rise across the heat exchanger. The formula is straightforward but precise. CFM equals heater output in watts divided by 1,200 and the temperature rise in degrees Fahrenheit. Or more commonly, CFM equals heater watts divided by 1,200 multiplied by delta T. Start by measuring the air temperature entering the furnace cabinet and leaving the supply plenum with a quality probe thermometer at steady state, taking readings after the system has run for at least 5 minutes at steady blower speed. Convert the electric strip heater nameplate voltage and amperage into watts by multiplying volts by amps, and for gas furnaces use the furnace's rated input BTU per hour converted to watts to combine heat sources if needed. When using an electric strip heater, only use the strip heater's electrical draw for the watts term. Do not add transformer or blower motor watts because those do not contribute heat across the heat exchanger for the air being measured. Ensure accurate delta T by averaging several readings across the supply plenum width and using insulated probes to avoid radiant influence. Avoid taking return temperature inside the filter cabinet where bypass leakage skews results. Correct for multi-speed blowers by testing each speed separately and report CFM per speed. If the system uses variable frequency drives, lock to a steady frequency for the test. Always document ambient conditions and measurement locations so later field verification or code inspection can match your method. One of the biggest mistakes is including transformer and blower amperage in the airflow calculation, which inflates watts and gives a falsely high CFM. Fix this by isolating and using only the electric strip heater's measured watts or the rated heater watts from nameplate data. One of the second common issue is taking single point temperature readings leading to noisy delta T and wrong CFM. Fix this by sampling multiple points across the supply and return, averaging, and confirming steady state operation. One of the third frequent problem is failing to convert gas furnace BTU to equivalent watts correctly when combining heat sources, producing calculation errors. Fix this by using the conversion 1 BTU per hour equals 0.2931 watts and summing properly before applying the formula. BigHomeProjects.com lists verified HVAC and home contractors so homeowners can find trusted local professionals who verify airflow, temperature rise, and system balance. The directory helps contractors get work by connecting skilled technicians with homeowners searching for accurate HVAC testing and best practice installation.